In this video tutorial, we'll cover the exploitation of our Windows target. One of the things we'll get started with is making sure that your Windows target as well as your Kali VM are powered on and functional. You're signed in. Use the provided credentials for your VMs. So once you're inside your Windows Server 2016, make sure that you look into your IP configuration. So click on the Start menu, type in command prompt or just left click if it's showing up. Then type in the IP config command and make sure you record the IP address for your virtual machine. My environment may differ from your environment, so make sure to translate the IP address that you see on the screen to your own. And then the other thing that I recorded is the host name. By executing the host name, this is the name of the computer, my Windows target in this case. So the next thing is to make sure that we have Kali, we're signed in. And what we will start doing is reviewing our Nmap. Yes, it's kind of interesting. We're not necessarily going to the vulnerability scanner, we're going to Nmap. And the reason for this is, from my perspective, Nmap gives me a very detailed view of the attack surface. Vulnerability scanners are going to give me some, low-hanging vulnerabilities, perhaps validation that can expedite the process. But ultimately, Nmap gives me, if properly executed, a very holistic view of the different open ports, running services, and information about the target. So I'll use Nmap as my guide, as my marker, to make sure I've covered and I've validated all the different vulnerabilities. You can use OpenVAS or Nessus as long as you make sure that they were configured properly to scan for all of the same ports. So Nmap, to me, it's a lot easier and less time consuming than OpenVAS and Nessus. Nmap is not a replacement for OpenVAS nor Nessus. It is just a guide. It's a marker. It helps me go through and validate things. To get things started, the first thing we see is there is anonymous FTP. With anonymous FTP, we see that we have incoming folder, and in this directory we have read, write, execute. What we can do with this folder, we can drop a file there, and I'll demonstrate this a little bit later. The file that we drop can be through anonymous FTP that we can import files to, improperly configured network file server or share, or a web server that delivers different content, let's say in an email or through drive-by. If you're clicking through different websites and you're going for content, we can deliver malware this way. The other thing that we see here is FTP bounds. So with the FTP bounds, we can use the FTP server to essentially enumerate and do a lateral type of reconnaissance of existing targets, and the source will be the actual IP address of our target, internal address, as opposed to an external address. So with this, FTP is trivial, much like the Linux system, so we're not going to spend a whole lot of time on this. We're going to go into the next section, which is port 80. We see that we have HTTP open port 80. We see that we have the version of the Apache, so we can look into exploit DB and search for available exploit and try our luck. The next thing that we see here is that we have XAMPP in a particular version, 173. So that's kind of interesting. So if we look into XAMPP 173, and for a fact I know that there is a vulnerability that allows shell access with full administrative privileges. So what we can do is we need to make sure that we have Armitage started. So left click on Armitage. If before this you haven't looked into Armitage, make sure that you have the database started. So execute service, then the database, and the start command. There's the spaces in between, and then you can either type in Armitage from the command line or left click on the icon on the left hand side. Once Armitage is started, what you can do is in here type in XAMPP. Okay, and we see that we have the XAMPP web dev vulnerability. Okay, so with XAMPP web dev, what we can do is make sure the local host is set up. This is the IP address for my Linux Kali machine, so leave that as default unless it's different. We have a default password known for the vulnerability. We have the default path, and then we have the remote host. So make sure you enter the remote host. This is the IP address for your Windows target. Okay, leave the default port 80, and then leave the default username. Then click launch. So what's going to happen upon successful execution is you'll be able to establish a shell. And what the shell would look like, if you're looking through here, we're attempting to execute the payload, and the payload essentially is default username and password. Okay, so what's going to happen here is we're going to have a session that will be opened. With this session, what we can do is interact with it, and if we select a command shell, the command shell is going to be just a command-like opportunity to interact with the host. Now remember, this is a Windows host, so you're going to have the $, but it's really a Windows machine. So what you can do is if you type in the command "who am I," you will see that the administrator account is the one you're actually logged in with. This gives us a full administrative control. So from here, what we can do is we can add a user, we can add the user to the administrator group, we can execute the directory command, and that would give us a listing of the available files and folders and stuff like that. Now, the other thing we can do is we can open up an interpreter session. And once we open up an interpreter, what we can do is we can type in the help command. So if we type in help, and let me bring this into full screen so it's a little bit easier to view. If we type in help, we're going to see different things that we can do, and it's a lot more, with the mind of post-exploitation and functional than actually just the shell. So we can do keystroke logging, so remote keystroke logger. We can record the mic, the microphone, the desktop, very creepy stuff. We can actually see who is in front of the computer. We can also elevate our privileges with the purpose of dumping hashes. So let's go ahead and do that. So let's do hash dump. If we do hash dump at the beginning, we're not going to be able to because we don't have enough privileges. So executing the hash dump command, pressing enter, will result in an error message that we don't have enough privileges. So what we need to do then is we can execute the get system command. Okay, using the get system command, we'll be able to leverage available post-exploitation techniques to get actually a system. So what we will do is get system. Type in get system, and I'm trying to scroll down through the actual window where I've done that. Let's see, get system. Got system. Okay, so now what we need to do is we need to look into and migrate our interpreter session to a process that's running as administrator. Okay, so anything that's running as administrator. So we see the explorer.exe is running as administrator. We see the cmd.exe is running as administrator. My preference is explorer.exe, something that's very common. Or we can do the svc host.exe. So what we need to do is execute the migrate command and then grab the process ID for explorer.exe, which is 2940. So looking through here, we'll execute the migrate command, and then 2940, which is right there, 2940. And from here, what we're seeing is we're migrating from the process that we were running as to 2940. And then if we see the successful migration, this will allow us to run with elevated privileges. And then if we execute the hash dump command, we see now that we dumped the hash for the administrator account. We can copy those, and then we can save it to a text file. And from there, we can use John the Ripper to actually crack those passwords, if they're easy to guess. You know, the Windows password is actually available, so you'd know that. Now, from here, we exploited the WebDAV XAMPP vulnerability. What happens when we go to the web, to the actual browser? We see that we have a web server. So if we fire up the browser, and we just type in the IP address of 172.17.90.101, we see the XAMPP shows up. Okay, now obviously if it's a web server, there'll be different directories and files that are accessible. How can I find out what directories, what files are accessible? We can do that through using a tool called Directory Buster, or DIRB. DIRB is a command line alternative to Directory Buster, and what it helps us to do is discover any directory listings based on a common word list dictionary. So this tool is going to go in and try to find iterations in available directories. What this looks like is if you type in DIRB and then you type in HTTP, the IP address of our server, and because we're seeing through Nmap that there is a server running on port 80 and 443, we can run through both scenarios. So change the HTTP to HTTPS over here, okay? And that's going to provide other results. We're seeing that some of the directories that he discovered is index.html. So if I click on this index.html and go into open the link, look what happened. It works, and I see that XAMPP is running, and look at this. I have a username and a password that are misconfigured. And if you recall, this is the same username and password from the actual exploit we ran a few minutes ago. Now, looking through the list with available directories, you'll find out that there is index. Anything with a code of 403 is not going to be, accessible. Anything, see the directory licenses, these are actually returnable. These are, code 200. Code 200 is success, so this exists. So anything code 200 is going to exist. Anything with a directory means that there's directory listing. There are things that exist there. So you see the server info, the server status, these actually exist. So if you go to these URLs, you're going to find some content. Again, server contact, server info. In here, we see that there's a directory, phpMyAdmin, and this is the administrative interface for the web server. So looking to phpMyAdmin, if we're to kind of look through the configuration, we see that we have an SQL database. If you look into the actual database that is available, there is a database called MySQL, and the MySQL database has different tables. One of these tables is the table user. So if we go in and we're to print view the contents, we see that it's where the username and passwords are. So essentially we can get the username and password of any user account that's configured. Now, in addition to this, eventually we can find out that in the security directory there is a XAMPP security PHP, and in here we can reset the username and password for the MySQL super user. So this is all the information we discovered from Nmap, and leveraging the information from port 80 and using XAMPP and 173 as the common denominator. Now from there, what we also can do is we're seeing that going down the list, we have a Mercury, SMTP POP3 service, and then we also have SMB. SMB is server sharing. It's a server sharing. It's a Windows file server. We're seeing that we have potentially a file share. It says that it's open, and we're seeing that we're running server 2016, the latest edition. So what we can do with this is we can try to enumerate these shares and find out if there's some low-hanging fruits. So the way to do that is open up command line. With nmap, we're finding out that obviously we have the shares open, and we also are seeing, we know the IP address. We're seeing through the list the actual host name for the system we're evaluating. And this host name is going to show up in there. We've seen the host script results. We see the computer name is this, okay? And then we have the IP address. So what we can do is we can use the SMB client command. So from a terminal, execute SMB client -l to list, and then we're doing / the name of the computer, which we got from the nmap result up top. Then we're using the -i for the internet address, and we hit enter. At the enter here, we ask for password. This is the password of the root account on Kali that we're logged in with. The password in this case is Tor. Type in Tor, press enter, and then look at the result. The result is these are the different shares that are available on the Windows system. Anything with a $sign is going to be a default admin share. Anything else is going to be a share that we can potentially connect to. So let's look into the XAMPP share. We can use the GUI to go in and connect to other locations. And in here we type in SMB. We type in : // pay attention to the direction of the /, the IP address XAMPP, and then we could connect. In here we can try to log in as anonymous. Click connect, voila. So we have anonymous share actually configured. With this anonymous share, we can check and see what kind of permissions we have. We can execute a script, or we can try the manual way. In our case, we have full access. So in here we can drop a file, and we can exfiltrate information. So if you look into the passwords file, if we were to open this up, look what happens. The XAMPP directory improperly shared. There's no password for MySQL. The file 0, there's a user password, anonymous FTP, Mercury, this is the username password, this is the web dev, and so on.